In Unit 4, we're going to be studying trigonometry. Most of you are probably familiar with SOHCAHTOA, law of sines, law of cosines. We're going to be taking a look at some higher level trigonometry in this unit. But we are going to start with a review of some of the basics. So trigonometry just means measurement of triangles. Most of you, again, are probably familiar with using trig on a lot of different types of triangles, and triangles that aren't necessarily right triangles. For example, when you use law of sines and law of cosines, it did not need to be a right triangle. For those of you that may not remember or may not have ever learned about the other three trig functions, there are 6 total. So sine, cosine, and tangent are the ones that I expect you to be familiar with. And then we're also going to look at the reciprocal for each of those functions. The reciprocal of sine is cosecant. CSC is the abbreviation. The reciprocal of cosine is secant, SEC. And the reciprocal of tangent is cotangent, COT. So those are the ones off to the right here. Now, I always get messed up because the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. So I always have to remind myself that those are backwards from what you would think. You would think the reciprocal of cosine is cosecant, but it is not. So when we look at a right triangle, remembering theta, hopefully you've seen that symbol for an angle before, the sine is opposite over hypotenuse, the relationship for the sine ratio for the angle. Cosine is adjacent over hypotenuse. Tangent is opposite over hypotenuse. Most of you should be familiar with that from SOHCAHTOA. And then, as I mentioned, the cosecant, secant, and cotangent are the reciprocal. So when you look at the relationship from the sine opposite over hypotenuse, cosecant is hypotenuse over opposite. Same for secant is the reciprocal of cosine, hypotenuse over adjacent, and cotangent is adjacent over opposite. So the first thing that we're going to practice is setting up those ratios. Hopefully by the end of this video you will have an idea or a beginning piece of information for being able to evaluate all 6 of the trig functions, as well as solving for a missing side in a right triangle. So taking a look at our first example, we need to set up the ratios for all 6 trig functions, but if you notice, we are missing the hypotenuse. So before we can set up our ratios, we need to know what the hypotenuse is. Some of you may recognize this as a Pythagorean triple. The sides are 3, 4, and 5. If you do not remember or recognize that relationship, you can always use Pythagorean theorem to set it up, and I will assume that you guys know how to use Pythagorean theorem for that. So sine is opposite over hypotenuse, so looking from where theta is, the side opposite is 4. The hypotenuse, of course, being across from the right angle, is 5. I'm jumping down to the cosecant because that is the reciprocal of sine, so we're going to flip that around. Cosecant is 5 over 4. Cosine is adjacent. Adjacent means next to, so we're looking for the leg next to theta. So 3 over 5 for our cosine. Secant is the reciprocal of that, 5 over 3. And finally we have tangent and cotangent. Tangent is opposite over adjacent, so 4 over 3. And then the cotangent is the reciprocal, 3 over 4. Our next example, we are asked to sketch a triangle given the cotangent. So what we need to remember is the cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So when we set up our triangle, doesn't matter which way you orient it, I'm orienting it differently on purpose so that you guys don't get comfortable with it always being, the right angle always being in the lower left hand corner. Call either angle you want theta, and then from theta, the adjacent, the leg next to it, we have a cotangent of 5, so it would be 5 over 1. The opposite from theta would be the 1. So we need to solve for the hypotenuse again in order to set up the other 5 trig functions. So we have 5 squared plus 1 squared equals c squared, or the hypotenuse. 5 squared, of course, is 25, plus 1 is 26. So when we solve for c, we get the square root of 26. And then we're going to set up those other functions from theta. So sine of theta. So similar to log functions, where you have to be taking the log of something or the square root, you have to take the square root of something. Same for the trig functions. You need to be taking the sine, cosine, tangent, etc. of an angle. So in this case, we don't know what the angle measure is, so we're calling it theta. So opposite over hypotenuse. And to rationalize our denominator, because we don't leave radicals in the denominator, we're going to multiply by square root of 26 over square root of 26. So we have square root of 26 over 26. Instead of finding cosine next, I'm going to find cosecant, which is the reciprocal of sine, and I'm going to flip the one where the radical was in the denominator so I don't have to rationalize it again. So flipping 1 over the square root of 26, I get the square root of 26 for my cosecant. Cosine of theta will be adjacent over hypotenuse, so 5 over the square root of 26. Rationalizing again by multiplying by root 26 over root 26. Sorry, my handwriting is terrible today. It's been a while since I've recorded a lesson. We get 5 times the square root of 26 over 26. And again, I'm going to jump to the reciprocal of cosine, which is the secant. I'm going to do the reciprocal of the one that is not rationalized so that it automatically becomes rationalized when I flip it. And the last one is the tangent function, which is the reciprocal of cotangent. Tangent is 5. The reciprocal of that is 1/5.